Okay, so did we lost somebody along the way? Okay, that's too bad. Okay, good, perfect, yay. Okay, let's go ahead and get started. So I want to go through mean, median, mode, range, and standard deviation today. So let me share my screen real quick. Okay. So make sure that you're taking notes on what I cover in class. Okay, if I ask a question, make sure that you answer it. First person to get the correct responses will get spins. So make sure that you're on top of it. Make sure that you put your cell phone away. Can you show me your cell phone and put that away? Can everybody show me your cell phone and that you're putting it away? That would be wonderful. Okay. Okay, great. Okay, so again, we're going to talk about mean, median, mode, range, and standard deviation. Okay, mean, median, mode, range, and standard deviation. Okay, what's the mean? Well, the mean is the average. Okay, how do we find the average? We take the sum of the data over the number of items. Okay, our data values. Okay, what about the median? Well, the median is the middle number. Okay, it's the middle number. And yeah, we'll just leave that for there right now. Okay, the mode. What's the mode? The mode is the number that occurs most often. Okay, what's the range? The range is the difference between the highest and lowest values. And what's the standard deviation? Well, the standard deviation is a measurement of how spread out the data is. Okay, it's a measurement of how spread out the data is. Okay, so I'll give you a second to finish copying that down. Okay, the mean is the average, which is the sum over the number of items. The median is the middle number. Okay, and I should say really middle value, not the middle number, because if I have an even number of items, it's really not the middle number, it's just the middle value of the data set. The mode is the number that occurs most often, and sometimes there can be no mode. No mode is possible. Okay, no mode is possible. The range is the difference between the highest and lowest values. And the standard deviation is a measurement of how spread out the data is. Okay, is it really spread out or is it really close together? Okay, so let's do an example with these. Okay, so let's take 4, 5, 5, 5, and 6. And we'll call this data set 1. Okay, so that's data set 1. 4, 5, 5, and 6. And then we're going to take, and we're going to find the mean, the median, the mode, the range, and then eventually we're going to take the standard deviation, but we're going to save that for a little bit. Okay. So what's the mean? How would I find the mean on this data set?
Mr. Hultman, I don't think we can see the data.
Oh, you can't see the data?
No.
Okay.
Or can the rest of you guys see the data? Or you guys can?
I can.
Yeah, Noah, you can see it? Okay, it might just,
Yeah, I can.
okay, you can keep going then. It might just be an error on my part.
Okay. Okay, so the data is 4, 5, 5, 5, and 6. Okay, 5 pieces of data, 4, 5, 5, 5, and 6. Okay, the mean, what would the mean be? Well, it would be the sum, 4 plus 5 plus 5 plus 5 plus 6, all over the number of items. Well, how many items are there here? Yeah, there's 5 items, right? Okay, so I'm going to add all these together. I'm going to use a calculator to help me do this. Okay, and as you can see, when I plug it into my calculator, I get 4 plus 5 plus 5 plus 5 plus 6, okay, is equal to 25. So this is going to be 25 over 5, which is 5. So the average here, the average, or what I'm going to call X bar, the average was 5. Okay, that was 5. Sorry, my 5 doesn't look like a 5, but it is. Okay, what's the median? What's the middle number here? Does anybody know? Anybody know what the middle number is?
5.
5. Who is that? Gabriella?
Mia.
Mia. Okay, so Mia said 5. You are absolutely correct, Mia. So Mia, you have earned a spin. Okay. Okay. The median here is 5. It's the middle number. Why? Because there's 2 numbers below 5 and there's 2 numbers above 5, and 5 is the middle number. Okay. Okay, what about the mode? What would the mode be? Okay,
5 as well.
Yeah, the mode is 5 as well. Who is that?
Noah.
Noah. Okay, Noah, you've earned yourself a spin. Okay. The mode is 5 as well. Okay, so why is the mode 5, Noah?
Because it's most repeating.
Yeah, it's the one that repeats the most, exactly. So we've got 3 5s here, right? We've got 3 5s. And so 5 is the one that occurs the most. Okay, so now what's the range? What's the range? What's the value for, yeah, 2. Who is that?
Matthew Lopez.
Matthew Lopez. Okay, so thank you, Matthew. You've earned yourself a spin as well. Okay, so we've got Noah, Mia, and Matthew on the board for a spin each. Okay, so yes, absolutely, Matthew. 6 minus 4 is 2. Okay, 6 minus 4 is 2. Okay, and that is the range. Okay, standard deviation is a little bit different. Okay, in that standard deviation, is a measurement of spread, how spread out this data is. So I'm just going to put a question mark here. What the heck is the standard deviation? What the heck does that mean? Okay, and I'm going to graph my data. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I were to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, where are my data values going to be located? Well, I'm going to have 1 at 4. I'm going to have 3 at 5. And I'm going to have 1 at 6. Okay. Okay. Now let's look at data set 2 here real quick, because I want to compare 2 data sets before I define what standard deviation is. I'm going to turn that off. There, thank you. Okay, so let's look at another data set real quick. We'll kind of like put a pause on what is the standard deviation yet, and I want to go to data set 2 here. Okay, so what's data set 2? Okay, data set 2 is going to be 1, 2, 3, 9, and 10. And what I want from you guys is I want you to find the mean, median, mode, and range, and put your answers in the chat box. I want the mean, median, mode, and range. And I want you to type those answers in the chat box. Okay, and send them to me as a chat. Okay, so I'll give you a couple minutes to calculate all of this out, and then send me your answers in the chat box. So 1, 2, 3, 9, and 10. Well, mean, median, mode, and range. Okay, so let's see what you got there. Okay, so Matthew says mean is 5, median is 3, mode, no mode, and the range is 9. Okay, Noah says mean 5, median 3, mode, no mode, range is 9, and Mia has the exact same thing. Okay, so you guys were absolutely correct. Okay, now let's talk about standard deviation. Let's look at the data set for data 2 here. Okay, so going to data 2, okay, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so for this data set, it's going to be 1, 2, 3, 9, and 10. And I want to look at these and compare these two data sets real quick. Okay, so if we compare these two data sets, okay, data set 1, the data values are really close together. They're all kind of bunched together. Okay, so this what we say has small spread. Okay, this has small spread. Okay, and things that have small spread are very close together. We say that has small variation. Things that have small spread have something called small standard deviation. Okay, it's small standard deviation. Small spread, numbers, items bunch really close together, small standard deviation. Now, what about data set 2? Well, does data set 2 have large spread or small spread? Does data set 2 have large spread or small spread? What do you think?
Large.
Yeah, who's that, Noah?
Matthew.
Matt. Okay, so Matt is absolutely correct. It has large spread. The values are more spread out here. And so it has large spread. Okay, it has larger spread than the data set 1. Data set 2 has large spread. Okay, large spread. Okay, we're going to use StatCrunch now to find out exactly what that standard deviation value is. This is going to have a large, or larger, I should say. Okay, this should be smaller. This is going to have a smaller standard deviation. And this is going to have a larger standard deviation. And we want to find out what exactly are those numbers going to be. So we're going to go to StatCrunch right now. So everybody open up your browser. Okay, and log on to StatCrunch if you can. Okay, so I'm going to go to StatCrunch. I'm going to go to my StatCrunch. Okay, I'm gonna let that load. And then I'm gonna click on, well, I'm already logged in. So after I log in, I'm then gonna click on Open StatCrunch. Open StatCrunch. And after I click Open StatCrunch, this is gonna give me a spreadsheet to work with. Okay, Open StatCrunch spreadsheet. Okay. Okay, and I'd like you to give me a thumbs up when you've opened StatCrunch. Okay, so you in the participants, there's 3 dots, and you can click on those 3 dots, and you can give me a thumbs up in the participants window. And my thumbs up means that I am at StatCrunch and I have opened my StatCrunch to the spreadsheet. Okay, Matthew, thank you. I see that thumbs up. I appreciate that. Matthew's the first one with a thumbs up. I think Matthew got another spin for that. Okay, Noah, I see your thumbs up. Thank you. Michael and Alejandra, do you have yours open to StatCrunch too? Alex, do you have StatCrunch?
I do, but I can't do the thumbs up. So I click the three dots and then I can't do the thumbs up.
You can do the thumbs up? That's
Yeah, I don't know
awful.
why.
That is awful. Okay. What about Alex?
Alex, that's my, oh, is there another Alex? Because I have
Oh,
my
you have two Alexes. Oh, okay.
yeah.
Sorry. I thought Alex was an Alex.
Oh, sorry.
No, I forgot temporarily that your name was Alex. Okay. So you have an iPad and a desktop? Is that what you Okay, cool. Awesome. Okay. So we have Jaden and Matthew and Mia and Michael and Noah. Okay, awesome. Everybody's at StatCrunch. Perfect. Okay. So now I'm going to enter in those two data sets. I'm going to enter in 4. Okay, can everybody, hopefully you guys can see my StatCrunch. I'm going to be doing 4. I don't need editing tips. Thank you very much. I know how to use this. 5, 5, 5, and 6. That's going to be for my first column of numbers. So that's 4, 5, 5, 6. My next column of numbers is going to be 1, 2, 3, 9, and 10. 1, 2, 3, 9, and 10. So take a second to put these in. 1, 3, 9, and 10. And 4, 5, 5, and 6. Okay, so what we're going to do is we're going to run some statistics on this data that we have, and I'm going to go to Stat, click on Stat, and you see right there where it says Summary Stats. We're going to go to Summary Stats, and then I'm going to click on Columns. Okay, so once again, that's Stat, Summary Stats, Columns. Stat, Summary Stats, Columns. Clicking on that is going to bring up a screen that looks like this. And I'm going to click on var 1. Okay, I'm going to click on var 1. That's for my first one here. Okay, and what I want from var 1 is I just want the standard deviation because we've calculated everything else. So I just want the standard deviation. Okay. Now, if I want to do these both at the same time, I can hit Control on my keyboard and hold that down, and I can highlight both var 1 and var 2. Okay, but if you want to do them one at a time, you can do them one at a time as well. And I want the standard deviation. I want to calculate the standard deviation for both of these. And I'm going to click Compute. And what that does is it tells me that for the first data set, right, the standard deviation was equal to 0.707. Okay, for the second data set, the standard deviation was equal to 4.183. Okay, and does that make sense? Does it make sense that our first data set, okay, would have a smaller standard deviation or be less spread out than our second data set? Okay, yeah, it absolutely would make sense. Okay, smaller standard deviation for our first data set larger standard deviation for our second data set. Okay, so let me go back to the notes here and let me write that in. So what was the standard deviation for data set 1? Standard deviation for data set 1 was 0.707. What about the standard deviation for data set 2? Let me fill these in real quick. This is 5, 3, none, and 9. The standard deviation for data set 2 was 183 or 138? Let me go back to the screen. I can't remember. Yeah, oh, 183. There we go. Okay, is 4.183. This is a big number relative to the data values. This is a small number. Okay, that one number is less than 1. Okay, and so which one had the larger standard deviation? Well, larger standard deviation went to data set 2. Smaller standard deviation went to data set 1. Okay. Now, why do we care about this? Well, we care about this because we want to talk now about the characteristics of a distribution. Okay. I can never remember how to spell this. Characteristics. I don't know. Whatever. Good enough. Okay, characteristics of a data distribution. Okay, characteristics of a data distribution. Okay, so for a data distribution, we have 3 characteristics. We have shape, we have center, and we have spread. Okay, shape, center, and spread. Okay, shape, center, and spread. So for shape, okay, we want to know 2 questions are most important in statistics for the shape. Is it symmetric? And is it unimodal? And we'll talk about what those mean. Symmetric, what does it mean to be symmetric? Well, if you look at my face is symmetric. It means if you cut my face right down the middle, I would have a mirror image on both sides. So symmetric is a mirror image. Okay, so symmetric is a mirror image. That's what it means to be symmetric. So what would data look like if it was symmetric? Well, our nice bell curve is data set that is symmetric. It is a mirror image, and it's symmetric about what we call the mean, which is mu. Okay, mu is the mean. Okay, that's the symbol for mean is a Greek letter called mu. Not to be confused with Mewtwo, which is a genetically engineered Pokemon. Okay, but this guy is mu, which is a Greek symbol meaning mean or average. Okay, so it's symmetric. It's symmetric. The right side is a mirror image of the left side. So it's symmetric and unimodal. Okay, what does modal mean? Modal is the number of humps it has. The number of modes are the number of humps, okay, that my data has. And if it's unimodal, it means it only has one hump. Okay. Okay, center. In this class, we're going to talk about 2 measures of center, and that's going to be the mean, which is the average, and the median, which is the middle. Okay, and we've talked about that already. For spread, in this class, we're going to talk about the standard deviation. Standard deviation, what the heck? Where'd my stuff go? There we go. Standard deviation and something called the interquartile range. Okay, we're going to only talk about standard deviation today. Interquartile range will be tabled for another time. Okay, what would be considered not symmetric? What would be considered not symmetric here? Well, if I had something that looks like this is non-symmetric. And if I were to like think of this as like a little slug, okay, little slug man here, okay, and it's a little slug going out, okay, for a walk, moving this direction. If our data looks like this, we say that this is right-tailed. And why is it right-tailed? Because it looks like it's got a tail on the right side. We say that it's right-tailed or right-skewed. Okay, right-tailed or right-skewed. Okay, the other would be true if it was left-tailed or left-skewed. Okay, left-tailed or left-skewed. Okay, what would be an example of non-unimodal? Well, how about something that looks like that? Okay, this is multimodal. Or if we got rid of this one, okay, that mode there, we would say that this is bimodal data. Okay, or only two humps. Okay? Okay, and I think that's where we're going to leave off for today. I'm going to see you guys back in here on Monday. Okay, and I'll leave you in Alejandro and Michael's hands at this point, okay?
Okay.
Thank you.
Yeah, you're very welcome. Okay. Let me make sure that I give Alejandro the host privileges before I leave.
And you guys can go on break, get something if you want until 11.
Sounds good.
Hey, before we get started, did you want to do the spins from the lecture,
Okay.
or when they come back?
We can do it without him, right?
Yeah. How'd it go with your talking in colleges?
Well, I received an email from my advisor that grades were going out this week, so I decided to just wait.
Oh, okay, nice.
How else having people over at the store?
It was busy,
Oh yeah.
really busy.
All right. Whoever was first got a 5,
5. All right.
a 1, a 3, a 2.
And that should be it.
Okay.
Yeah, because Mia got 1, Matthew got 2, and Noah got 1.
All right, and we're back. So today's the main point that you guys want to get out of here is memorizing those three. How would you describe it? They're components. You use it to describe the distribution or analyze it. It's always shape, center, and spread. So just get used to that. Shape, center, spread, shape, center, spread. You guys need to know that. When they refer to the shape, it's just the shape of the actual graph. So like unimodal, that means one little bump. So you see this little like, you see how it's only 1? So uni means 1. So it's only 1 bump. The next one is bimodal. You see how it has 2 bumps right here? So bimodal, 2 bumps, and then many bumps, that's multimodal. Okay, so we want to see which one of those 3 it would satisfy. Then we also want to check if it's symmetric or not symmetric. So if we were to like fold this down the middle, that would land right on top of each other. If we fold this one down the middle, it lands right on top of each other. But these 2 right here, if we draw a line and we fold it, it wouldn't lie on top of each other. So those are not symmetric. And then the last thing we want to talk about shape is whether it's a bell shape. So all of you guys know what bells look like, right? It's kind of like that. Okay, so here on the left, that's a bell shaped. Or something on the right, one looks more like a triangle. The other one's kind of more to the side, right? So these three things are important when talking about the shape, how many bumps it has, if it's symmetric, and if it's bell shaped. Okay. So looking at those descriptions, there is a couple of shapes that we can just kind of summarize. So the normal distribution underneath here usually says shape, normal distribution, and it looks like this. There's three things that characterize this. It has to be symmetric. So if we draw a line down the middle and we fold it, it should lie right on top of each other. It should be unimodal, so that's one hump, right? And it has to be bell-shaped. So, and this little thingy, the shape of it, it does matter. So try your hardest to make it. I know it's hard, but that's a normal distribution. It has to have those three things: symmetric, unimodal, and bell-shaped. Okay. Another famous shape is skew distribution. That's when you have kind of a tail on one side and then a bump on one side. So it's either the left or the right. And we always refer to these depending on the tail. So you see how on the left side here, this is the tail over here, and it's on the left side. So then this is called a left skew distribution. Then the one on the right has a tail on the right side. So this is called a right skew distribution. Okay. For these, there's two things that characterize them. It's unimodal, that means one bump, and it's pushed to one side, either the left or the right. And then it also has a big long tail to one side, which is going to be the opposite side of where the bump was. Okay. So now with normal distribution, that's describing the shape. Okay. And whenever you have normal distribution, the center attached to this shape always is the mean or the average, however you want to remember it. So normal distribution means you're going to have a center using the mean, and then the spread that you're going to be using is the standard deviation. So here I have the formulas for the standard deviation, but you don't really need to know these. We're going to use StratCrunch to calculate them. And then for the mean, I also have the formulas here, but it might be more confusing than what it actually is. You just add all the values, divide by how many items you have, which we can also get from StatCrunch. And then whenever you have skew distribution, the center that you're going to be using will always be the median. And then the spread, you'll always be using the IQR. Okay. So out of this lecture, this is the thing that you guys want to memorize here and that I circled. Describing or analyzing a numerical distribution, there's three things: shape, center, spread. Normal means that you're going to be using the mean and standard deviation. And if you have skew data, more to the left or to the right, you will be using the median and you will be using the IQR. So all of these always come hand in hand. These three and these three. We can never mix and match. So write that somewhere. That's really important that you guys know from today. And the median and the IQR, they weren't covered today, but they're going to be covered tomorrow. Just start associating skewed with median and IQR, and normal with mean and standard deviation. Okay, now for the spread, I just want to show you this little drawing here. The spread talks about how much variation there is, right? Like Hultman said earlier. So you see the graph above. The graph, it has a lot of variation. It's from here until here. But the bottom graph, it's only from here to here. So this one has more variation. And this one has less variation, right? That means that this one that has more variation will have a higher standard deviation, and this will be a smaller standard deviation. Okay. Does anybody have questions on any of this? Okay, so then there's these worksheets on Canvas. So for this, we're gonna be looking at, we're gonna be comparing them. So like for number 1, we have one graph A and one graph B. We wanna say which one we think has a larger standard deviation, okay? Or spread. Just think of which one has more spread. Okay, then we also want to talk a little bit about shape. So shape, we have, the ones that we're going to be using most of the time are going to be normal and a skewed. Skewed. Normal, it looks like a bell, and then skewed looks like a big bump, and then kind of to the side, like that, or like that, right? So for number 1, for 1B, can anyone tell me what the shape of that is?
Skewed left.
Skewed? Yes, skewed left. So you see how it does one of these, and the tail is this way. So skewed, and then the tail is in the left. So it's skewed left. Perfect. What about 1A? That one's a little hard to tell, right? Because it kind of looks like it could be normal. It kind of looks like it could be a little skewed. So you see how, look at the end values. So this guy here goes up until 2, and this one goes to 1. So this one's much higher. And then this one, we have this guy here and this one here, which this one's higher. So like if we imagine that this little block went here, then this would be equal to this, and then this one, and this one, and we would be here, and this one would be long. So it kind of looks like it could be normal. And you're gonna encounter a couple of these where you're a little unsure on what to do. You can always jump in here and ask us. So which one would you guys expect to have a higher standard deviation, A or B for number 1? No idea? Yeah, that one, okay, so this one, the part of A, it has a lot of data right here, and this is also really big and really big, right? So we have most of the data right here. The other one, we have the data here and here and here. So we have the data mostly here. Now, this one here, since it's kind of on the side, it'll be, this one is a little unsure. So if you guys were to put both graphs, that might be okay. Or if you put B has a higher standard deviation, that's also okay. Because this one, it has most of the data here and it has to spread out this way. So either of those two would be okay. What about for number 2? Which one would have a higher standard deviation? So which one's more spread out? Let me ask Matthew, which one would you think has a larger standard deviation?
B.
B, yes. Because A, we have the numbers right here next to each other, and this one, there's a space in between. We have more space here. So B has a larger standard deviation. Oh, wait, actually up on top here, I didn't notice that they gave us the these numbers up here. So we can actually tell which one is bigger, right? So this one, B, is a higher standard deviation. Okay, 3, which one has higher standard deviation? Let's try, Mia, what do you think? Oh wait, no, the number on top is not the standard deviation, that's the mean. They're giving you the mean, I'm sorry. So this one, sorry, scratch what I said. So 3, we just wanna see which one has a higher standard deviation, so which one is more spread out?
They look the same to me.
They look the same, yep. So then both graphs have the same standard deviation. They look exactly the same. Number 4. Jaden, which one do you think has a higher standard deviation? Which one has more spread out?
B.
B, okay, so let's see. So B goes from 1 to 5, right? And then A goes from 0 to 6. So since A has
You're right.
Mhm, mhm.
I even see that.
Yeah, so if you guys look at the bottom, that tends to be useful because you can see which one will be wider than the other one.
Right.
Okay, and then for B, this guy here, what shape would you say that is? Would you say it's more normal or skewed? I would say it's about roughly normal. So even though you might think that it looks a little skewed because of this is lower than this one, and then this one's really high. So if we were to take this from here and put it right here, it would be like this, and it would look more normal. So I would say this looks pretty much normal. Number 5, which one would have a higher standard deviation? So Noah, what do you think? A or B?
B.
B. Yes. So all of these are continuous here. Here we have a big gap, right? So it'll make this guy here a little bigger. Number 6, which one has a higher standard deviation? I asked everybody, so let's go again with Matthew. What do you think, 6?
B.
B.
Or would it be the same?
I think it's both.
I think it should be A because we have gaps in here. So gaps usually make our standard deviation bigger. 6. Okay, let me just check the answer key so that we know for sure. We were doing number like 6, I think. 6A is larger, yeah. So if you guys see these two, they both go from 0 to 6. Now the one, the B is all full, and A has gaps. Gaps you usually up your standard deviation. So in this case, A is gonna have the bigger standard deviation. Sort of like the one we just did right here, A5, they both go from 0 to 6. But part B, you see a big gap, that'll have a bigger standard deviation. Number 7. Oh, here's another thing that you should notice. Whenever your shape is like this, more the big are in the middle, then that will most likely have a lower standard deviation than if your big numbers are on the sides here. Okay, because over here you're gonna have a lot of values over here and in the ends. Therefore, your standard deviation is gonna be bigger. Versus if you have most of your data in the middle, your standard deviation will be smaller. So think when you're comparing these two, if you have most of the data on the sides, it'll have a bigger standard deviation. So number 7 will be B. B because most of the data is on the sides instead of the middle. What about 8? Mia?
Would it be B?
Yep. Mm-hmm. And it'll be the same thing. Even though this one does have something big over here and something bigger over here, this one has big here and also really big there. So B will have a larger standard deviation. Number 9. Noah, what do you think?
I think, would it be the same?
Let's see. This one has most of the data in the middle, right? This one, it seems like it has a lot here, but a lot over here. So since it's doing one of these guys here, it looks like this one might have a bigger standard deviation. Whenever you see something that looks more normal like this, normal will have lower standard deviation. So this one will be A. Okay, and you can see a kind of a pattern, right? So like number 7, it was like this, and this was normal, so it was B. And then 7, it's also like a bump and a bump, and this one, bigger bump and bigger bump, so it's this guy. This way, pump and pump. This one looks normal, so it has to be this guy here, A. Okay, we're almost done. 10, okay, so the one A has no gaps in between, and B, it looks like it's almost the same, it just has a bunch of gaps. These gaps will spread it out even more, so then this will have a larger standard deviation, B. Okay. And if I were to say what shape 10A is, I would probably go with skewed. It looks like the tail is going this way. So skewed right. Okay. 11. It looks like we're going from 3 to 9 on both. And it looks like this one is more skewed right. And it looks like this one's skewed left. But they look pretty much the same. It was just kind of like they're a mirror image of each other. So for that one, I would say they look about the same because there's not much difference in between both graphs. Okay. 12. All right, they go from 3 to 9, both of them. Now the one on the left looks like it has 2 bumps going on, and this one looks like it's just 1. So then the one with 2 bumps would have a higher standard deviation. Okay, 13 is the same thing. We have bump and bump, and this one is just 1 whole. And then let's see the numbers in the bottom. This goes from 1 to 10. So it looks like it's about 9. This one goes from 6 to 12. It looks around 6. So this one would be a little hard to tell, right? You see that? Because we have the shape of the left that would look like this one would be bigger. But then in the bottom, the values, it looks like B is the one that has more values in the bottom. So let's see what the answer key says. This was number 13. B is larger. Okay, so if you have that going on, go by the numbers in the bottom. This had a wider range than this. So then B should have the bigger standard deviation. Mm-hmm. 14. This goes from 2 to 12, that's 10. This one goes from 0 to 8, that's 8. The graphs look like they're kind of about the same. So since the bottom on the left is 10, it's bigger than the 8, it's gonna be A. A will have a bigger standard deviation. Okay, and then lastly, 15. And here it goes from 1 to 12, that's 11. Here it goes from 0 to 8. So it looks like obviously this one's bigger. It also has gaps here, which makes it even more. So then we know for sure A should be bigger. Okay, any questions on any of those graphs? All right, just remember you have to know shaper, center, and spread. Make sure that you know that for a normal, you're gonna calculate the mean and the standard deviation. And for skewed, you're gonna need the median and the IQR. Okay, now does anybody have questions on anything else So I can answer questions about anything, or I can start on another worksheet. Anybody need help with anything, or a stat crunch?
No, I have a question. It was regarding grade scope though.
Uh-huh.
I've still been having troubles getting into it for the past 2 days.
Into grade scope?
Yeah.
Let's see. Michael, would you happen to know about this?
Not too much. I saw they posted a new code today. I don't know if you tried that one.
Where did they post the code?
Should be in like the Pronto.
Okay. All right, I'll check. Thank you.
You were having problems just sign in?
Yeah. So when I clicked on it was something at the bottom where I was able to choose Cerritos,
Mhm.
and then it told me it was like an access portal through there. So I was entering my student ID and my password, but it kept saying incorrect. So when I went to my Cerritos and tried the same thing, it worked, but on Gradescope it wasn't working. So I didn't know what else to do. So I emailed Professor Hultman last night. He emailed me back this morning saying he would let me know what's going on, but he hasn't said anything yet.
Yeah.
I was having that same issue.
I was
What-
too,
what
but
that-
they emailed me this morning. And they like emailed it. They're saying that they're gonna add us. It's because when we were putting in our passwords and everything, it was saying like we're not like available, like we're not supposed to, like it was like some weird thing. So they said just to submit it with that, and they would like reach out to us with an email.
Yeah, and I never got an email.
You said you got an email this morning?
Yeah, I did.
And did they give you something to reset it, or did they give you some kind of access code?
Yeah, I'm just reading right now. It says to get started, you will first need to set your password. So basically, we're setting.
Oh yeah, I did get the email.
Oh, okay. Do you guys want to give that a shot? See if you guys can log in.
Yeah, that's what I'm gonna do real quick.
Yeah, it worked for me now.
Yeah, it's working now.
Perfect. And so, Matthew, you're able to get on Gradescope, okay?
Yeah, I just got on right now.
Perfect. Noah, you're good?
Mine says my account's locked now.
Your account's locked?
Yeah.
All right. I would just send an email to Professor Holtman and Professor Conley.
Okay.
I'll let them know that you're having issues.
All right. So. Okay, so we can either do this worksheet. I don't think we're going to be able to do both. So we can either do this one, look at our precedents, where we have to make a histogram, or we can do this other one, reading a histogram, where we give them information from the histogram that was already given. Which one would you guys rather do? A, make the histogram up here, or B, get information from the histogram. So A or B, which one would you choose, Matthew?
I was messing with the grade scope right now. I'm sorry. Can you repeat that?
So option number A is we do this worksheet and we make a histogram, or option B, we read information from a histogram in worksheet B.
Worksheet B.
B. Mia, what do you think?
B.
B. Noah?
B.
All right, so then it doesn't matter because we're doing B. Reading a histogram. Okay, so they give us a histogram, which it looks like it was given from a calculator, from a graphing calculator. And it tells us that the minimum value is 40 in our window. So this right here, this is 40. And our maximum is 110. So right here, that's 110. And the scale is 10, so it's going by 10. So right here, this is 50, this is 60, 70, 80, 90, 100, okay? Then it tells us the Y scale is 5. So you see these little dots? This is 5 right here, this is 10, this is 15, okay? And then the graph tells us the minimum 70 and maximum less than 80. That means that we're in here, in this box right here, right there. And then N is equal to 15. That tells you the height of this box. So it tells us that up here, this point here, we're at 15, which is exactly what we have over here, 15. All right. Okay. So the first question is, how many students were in the class? So these people that are in this box, these got A's, right? From 90 to 100. From 80 to 90 got B's. From 70 to 80 got C's. 60 to 70 got D's. And then 50 to 60, those are F's. So if we want to know how many students were in the class, we need to add all of these up. So right now we know that in the C box, we have 15 students right there. Now in the B class, the bin looks like this is 10. So it looks like it's maybe a 13, maybe 12 or 13, somewhere around there. You just kind of want to give a good estimate. For A, it looks like it's right on the 5. So this is 5. For the D, it looks like it's also right on the 5. So that's 5 right there. And then F, it looks like it might be maybe 2. So now if we add all of these up together, that should be 20, 45? No, 40. Is that what you guys got too? Okay, you just want to give a pretty good estimate from the graph. So how many students were in the class? 40 students. Okay, how many students earned a C? A C, so it's that bin right there, which is 15. Students. Now, how many more students got D's than F's? So first, how many got D's? So D, 5 people got D's, and then F's, 2 people got F's. So they want to know how many more students got D's than F's. So how many would that be? More students.
3.
3, perfect. 3 students. Okay. Part D, what % of students passed the final exam with 70 or better? So 70 or better. So this box here with a C, this one is 70 or better, right? Because if somebody got like a 70, a 71, a 73, all of these, they would qualify because it's 70 or better. Now, also the next box, the box with B's, those people also have 70 or better. And then the A's, they also have 70 or better. So you just want to watch out for questions like these, when they ask you to add multiple bins together. So we have to add 15, 13, and 5. That would be 33. Percentage. Okay, so we know that 33 students got 70 or better, but they want to know what percent. So first we're going to take 33, which are the people that got 70 or better, and we're going to divide that by the total, which is 40 students. Okay, 33 divided by 40. That's 0.825. That's a decimal form. So if we want to turn it into a percentage, we're going to move the decimal place twice to the right, 1 and 2. So then the final answer should be 82.5%. Okay. And then what was the top grade in the class? So can someone tell me this, or does somebody know what the top grade in the class was looking at the graph, at the histogram? It's hard to tell, right? We can't really tell because we know that in the A box, there's 5 people there. So we know 5 people got A's, but we don't know if it was like a 91, a 91, and a 96, right? We don't know the specifics of what A they got. So this question, we can really not really answer it. So what we're gonna say is, we cannot tell specific information from just the histogram. Okay, because we don't know what the highest score in the class was. We just know that 5 people got A's and that's all we know. Okay, so that's kind of the problem between making histograms. Sometimes we lose important data, but histograms tend to be really useful to like look at trends when we look at it in a table format. Okay. Any questions on this? All right. So I think we can do a little bit of this guy here. Okay, so we have here our presidents, lifespan of the 35 US president from George Washington to Lyndon Johnson are listed below. And we have their lifespan there. We want to create a stem and leaf plot for part A. So stem and leaf plot. I'm gonna go ahead and circle everything that I'm gonna combine. So every 60s, I want them together, 16, 16, 16, 16, 60, 16, 16, 60, 16, 16, 16, 16. This is important that you guys know how to do as well, making a stem and leaf plot, because the stem and leaf plot will allow you to make the histogram much easier. And then I also want to group all of my 50s and 70s together, 50, 50, 50, 50, 50, 80, 80, 80, 80, 70, 70, 70, 70, 70, 70, 70, 70, 70, 70, 90, 90, 49, 46. Okay, I think I circled everything now. Okay, and for the stem and leaf plot, I want to start with the smaller number first. So I have 40s, 50s, 60s, 70s, 80s, and 90s. So I'm going to start with the 40s. So I have 4, and you see how I only have 2 40s. I have the 49 and the 46, and I want to put them in order. So the 6 goes first, and then the 9. Okay, so 46 and 49. That's the first one for the 40s. Then 50s. So I have a 5, And then my 50s are in pink. So I have 53, 56, 57, 8, and 7. So it's going to be 3, 6, 7, 7, and 8. 1, 2, 3, 4, 5. Yes, I think that looks right. So I did my 50s. Now I go to my 60s. So I have a 6, and then my 60s are in blue. 7, 8, 5, 4, 3, 6, 0. Okay, I have a 0, a 3. Oh no, I have another 60 over here. A 3. I have 64. Oh, I have another 63 there. So I need another 3, 4, 7, 7, 7. I have another 4 right there. 65 right there. 66. 67 and 7. 7, 7. Oh, 7 and 8. And I think that's all the blues. So let me scratch out what I've already done. This. I did the 50s. I did these, that, and that. All right. Now I go to 70s, which are in yellow. So I have 0, 1. So this one and this one. 2. Oh no, I have another 1 before the 2. 1, 2. Okay, I finished with this row. 7, 3, 4, 7, 8, and 9. Okay. That. This one, finished all of them.
Eisenhower's a 78 on the last column.
Oh, yeah, 78. So another 8. Thank you. Okay, and then now we go 8s. We have 3, 5, which are these two, and then 8. And then I need one more for the 9. 9. Oh, I forgot a 0 there. 0, 3, 5, 8. 0, 3, 5, 8. This guy here. And then 90, we have 2 90s. All right. So that's my stem and leaf plot. We also need to break a key. So 4/6, that means equal to lifespan of 46 years. Okay, this is the key. You always want to put a key whenever you do a stem and leaf plot. Did anybody have any problems creating this stem and leaf plot? No? Okay, good. So now, once you have this stem and leaf plot, just imagine turning your head 90 degrees. And you can kind of see, like if this was turned, you can kind of see the shape like this, right? When we make the histogram, it's kind of the same thing. Let me see. We're gonna here. We're gonna have our values down here. So like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I'm just making this kind of fast because we're gonna run out of time soon. So in the 4, you see how we have 2 values there? So then we are going to have 4, and then let's say this is like a 2. So we would only go up to the 2. The next one at 5, we have 5 values. So we would go higher to a 5. 6, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. So this one's gonna be pretty high. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So it's gonna be a little shorter than the other one. 8 to 9, we have 4 values. So maybe like here. And then the last one, we have 2 values, which is short like that. So you see how when we have the stem and leaf plot, this little shape that we have like this, if we turn our head sideways, it's the same shape as we have here, right? So when they give you big data sets like this, it's good to organize them in the stem and leaf plot, because after that, it's easy to transfer the data into the histogram. Right? Any questions on this? No. What does that shape look like? Does it look more normal or skewed?
Normal.
Normal, yep. Pretty normal. And you always want to be careful with these histograms, because you're the one that's deciding how big you want the bins. So these are like the bins. This is one bin, the next bin, the next bin. So in this case, we went by tens, right? Here we put everyone that went from 40 to 50. Here anyone that went from 50 to 60. Here everybody that went from 60 to 70. It doesn't have to be exactly that way. You guys could always make it by fives if you wanted to. So like 4, we have 4, 4, 5, 5, 6, 6, 7, 7. And so the same data that I have over here, the first row would be from 40 to 45, which I don't have any. So I would fit the 6 and the 9 here. Then for 50s, I would first, in my first row, anything below 55. So 3 would go there. And then the next one would go 6, 7, 7, 8. And if I did it that way, my bins would be half the size. So instead it would be maybe like this one didn't have any, and then here we had bigger here. This one would be here like this one may be bigger, but everything would be split in half and the heights are gonna be different. You know what I mean? So it might look something like this in pink. Like that instead. So it's always your choice on how you wanna make it. Big or small. Just make sure that you use something that gives you a good shape of the graph. Like there was in the text mentioned that a bad example for something like this would be a bin size of size, let's say this goes from 40 to 90. So let's say our bin was of size 50. So then it would go from 40 to 90 to, yeah, 90 here. And since all of these are in the same bin, we would just have one straight bin like this with all of the data that we have there, right? So that wouldn't really be that useful because we can't really tell. So most of the time, if you go by tens, that's gonna give you something good. Any other questions? We're good. Okay, so I think we might be good for today. Michael, anything else? No, right?
No, that should be it. If you want to do their spins before they head out.
Oh. Alrighty, so Matthew, you get 1 point. Mia, 5. Noah, 2. And then did we lose somebody?
Yeah, Jaden left. I'm not exactly sure what time.
Okay. All right. Thank you, guys.
Thank you.
Thank you.
Have a good one.
Thanks, guys. Have a good day.
You too.
Oh, I was gonna tell Noah. Dang it.
What were you gonna tell him?
Oh, he can go to tutoring. And Angie will be there to talk with him.
Oh.
Let's see. Can I message people directly?
extension, helping your teeth become 4 times stronger, preventing cavities up to 40%. Act Kids Fluoride Rinse. Stop imagining. Start acting. And now, get anti-cavity protection in real, dye-free ice formulas. You can hydrate by staying a necklace. Or let your neck make the statement. Gold Bond Neck and Chest Cream improves texture, increases elasticity. 97% had firmer skin. Gold Bond, Ultimate Lotion, Ultimate Skin. I put your new prescription in the pharmacy. Any idea how much it will cost? You have a choice. Insurance or GoodRx? I have insurance. Insurance is not what it used to be. People struggle to get their prescriptions covered, and prices keep rising. I recommend GoodRx. You get free coupons to save on the prescription. Compare prices to find the best discount. GoodRx. Smart. Stop paying too much.